to the presentation. Before that, we need to thank our sponsors. So CAD Connect is the industry issue with the architectural and structural use of CAD steel components in the design and construction of building and bridge structures. Products include pre-engineered connectors that simplify the design and enhance the performance of structures. Also offer design build services for custom CAD steel knobs and components.
And we would like to thank our second sponsor, our silver sponsor this year, Intuitive U. Intuitive U is a student platform that provides students with a tangible experience in the life of a real engineer through participation in several activities based on real intuitive projects. It also gives students and recent graduates a meaningful connection to the industry by connecting them with subject matter experts. We really thank their support this year, and we hope you guys can support us next year as well.
And we also need to thank our supervisor, Professor Christopoulos, also grad student everyone, and Aaron to help us to have this shape pad. So tomorrow's tower. So our project vision is to design for climate sensitive resistant tower, and its design is mixed-use design with integrated indoor and outdoor space. We do the design iteratively based on the first principle, and our goal is to maximize value for architecture. And we'll talk about that.
So hey guys, we're going to talk a bit about the architecture this year. So tomorrow's tower is a mixed-use tower with square floors, which blends it into Salt Lake City skyline of heavy-set rectilinear towers.
In terms of our goals of the tower, we were hoping from the architecture facade perspective of things to design and consider. We want to aim for a lighter, more futuristic architecture facade using curtain wall systems instead of traditional window wall systems of bridging, removing the effects of thermal bridging, more energy efficient construction, and also lighter construction in terms of materials such as using glass fiber reinforced concrete to improve sustainability and reduce the weight of the overall envelope system. In addition, because there is no timber industry within the state of Utah, using traditional materials such as glass and concrete and also different fiber reinforcement can create a more sustainable and facade construction for the future of Salt Lake City.
So a bit about the facade. The triangular pattern of the tower's facade shades the glass windows, reducing the need for cooling in the summer, and directly mimics the tower's interior structure. So the same pattern used on the outside is continued on the inner atrium for the first 7 floors, which creates an indoor facade that helps mediate between residential life and public life below. And finally, for the program of the tower is programmed with retail space, residential units, private and open concept offices, a shared recreational garden, and a lounge bar on its top floor. Additionally, the south wall is left unobstructed on the atrium floors to allow for more light into the hollow core. And the triangular facade acts as a green wall structure through the 11th to 15th floor, shading the recreational balcony. It also bends over the top of the tower to provide shade to a rooftop garden before continuing down the opposite side.
Thank you. Now I will talk about the geotechnical considerations for our tower. So our tower is located on alluvial and lucky stream deposits caused mainly by the recession of ancient Great Lakes. Our site is also located on the Wasatch Fault Zone, largest and most active on the Intermountain Seismic Belt. Now, with regard to our site considerations, our site is prone to liquefaction as a result of the presence of loose sand and silt and a very shallow groundwater table. With these considerations, in conjunction with the average shear wave velocity, average flow count, and average undrained shear strength of the soil, we have a site class of F without liquefaction mitigation and a site class of B with liquefaction mitigation. Some liquefaction mitigation techniques include soil replacement and soil compaction.
Now I'll go over our structural design this year. So this year we have encountered 3 major challenges in our group ideation process. First, the transition from the 8th floor to the 10th floor due to these continuous columns. So this year's SLC has really given us a huge challenge. So as you can see in this figure on the right, the columns from the top floor to the middle floor, it's like in the middle section. But then from the bottom to the middle floor, it's like on the outside. So in order to deal with this continuity, we have to put a lot of thought and effort into it. And this challenge also has led to our second biggest issue, which was constructability. Since we have to connect these 2 columns to make a rigid connection between the 2 parts of our tower of our structure. And the last challenge was the slenderness of the inner core. Our inner core this year was just 5.5. It's a 5.5 square, which is really slender compared to what we have in the past. So these are the 3 main challenges we had this year. So after we have came up with our preliminary design, we then use our in-house Python program, AutoBuilder, for large-scale iteration. So with AutoBuilder, we use different types of bracing schemes, and we also try different types of member sections. For example, for bracing scheme, we tried double axis, single axis that spans either single floor or 2 floors. And for member sections, we have like single columns and double columns. So for this year's design, we have made 4 major analytical assumptions. First being fixed connections. To ensure this assumption is valid in our structure, we have multiple gusset plates and very detailed connections at every single joint. Second assumption is that we assume linear elastic behavior. So in the past, from a past experience, we've noticed balsa exhibits linear elastic behavior before it failures. And since that we have designed every member to be under its capacity, this assumption is valid. Third, we assume balsa is an isotropic material for simplicity. Last, we assume classical constant damping with a damping ratio of 5%. So now I'll go through our overall structural concept. Our structural system this year can be broken down into 2 parts. The first part being from the bottom floor, from the first floor to the 10th floor, where we have prepared a couple of shear walls on the side, as you can see on this figure on the right. And the second part spans from the 8th floor to the 20th floor, where we have like shear walls coupled with a brace frame. It's like this skinny part on like the top portion of the structure. So this year, one of our design focus this year was to ensure that our lateral force resistance system was designed to be on the same plane of action. This is to ensure that we have an efficient load lateral load transfer from the top floor all the way down to our base plate or our foundation. In addition to that, we have additional exterior post-plate brace, post-tube bracing to provide torsional stability due to the given continuous torsional path. If you can go back to the previous slide, as you can see, the bottom of the structure is basically an octagon with braces on every single side, and those braces would be resisting any potential torsion that might happen during our shaping. Construction imperfection and material variability has always been an issue. That's why this year we did 3 vibration tests to calibrate our analytical model in SAP 2000. There are 3 major aspects that we calibrate. First is the density of balsa wood. The density of balsa wood was calibrated to match our final tower weight. Second, we calibrate our Young's modulus, the Young's modulus of Dawson would to match our tower natural frequency that we obtained from our free vibration test. And this year, our tower period is 0.15 seconds. Last, we calibrate the damping ratio of the time history analysis to match the damping ratio obtained from our free vibration test. And that damping ratio is obtained through the log detriment method. And this year we have a damping ratio of 5% as well, which agrees with our initial assumption.
Now I will go through the construction method. First, we did our model in Revit. Then we exported it to AutoCAD to make jigs. This year, we have 2 jigs, one for inner plan, another one to test for the outer plan. We first do the inner core assembly. We build the tube for the inner core from the 8th floor to 20th floor. Then we do those flaps around the tube. Then we have those interior shear walls added on it. Then we put the 4 plans to complete the shape and put the exterior core on it. When we do the frames, we use the jigs as shown on the picture. We make sure our plans will be flat and will be easy. Then we put them as shown here. And this is our finished tower. For the analysis result and prediction, for ground motion 1, we expect the peak displacement to be 0.19 inches, and for ground motion 2, the peak displacement will be 0.91 inches. For peak room acceleration, we expect ground motion 1 to have 0.82 g, and for ground motion 2 to be 3.64 g. The final value will be 292,000. And very nice this year is we won the best architectural award through the competition, and that's stands for our architectural lead this year. And thank you for listening. That's the end of the presentation, and we will start the shape testing.
Right now, like I can't even read 1 and 2. Okay, I can only read 1 and 2. Oh yeah. Okay. You know what? Okay. Oh wait. It's not up. It's right. So I don't know if these. Wait, Grace, cover the closer sensor with your hand. Yeah, so that one. So it's that way. So we need to, when we angle it up, it'll move this way. So we're still angling it up. It's just because it's rotated. Yeah. And I'm just going to drive this like down. It's just stuck actually because it's going to go pretty low.
I'm taking one off. Yeah, that's pretty hot.
Okay, can I get people that are not doing anything to just come out? Basically, we need someone to help Daniel just stabilize, just in case anything happens. And then I need someone with me because this is getting stuck on the teeth at the bottom. So put your hand here. And we'll kind of lift it like slowly, but yeah. Oh, wait. Stop. Well, no, you can't. In place of case for some reason, I think it's just ability to do that. I'll grab it and try Okay, someone go to the camera. Someone come. move all the way, like, we'll start seeing, these are going to start moving this way, and we'll start seeing four other dots, okay? That's what, yes, you have a moving rotating stuff, as they're moving stuff along. So just let us know when you see more dots, yeah? Okay. Okay, so you'll focus on this leg, and I'll focus on that leg. And
There's already
it's
four
really
dots.
vertical.
There's already 4 dots, but they're not moving towards the left side.
There's more dots.
Yeah, there's 4 dots now. All in green, but they're mostly on the
Four?
right.
Okay, tell me when there's 6.
When there's 6, okay.
They should be in the, oh, sorry. Sorry. Hold up for a second. There should be two on top, right?
Yeah, 2 like this, 2 dots in the middle.
Nice. Yeah, perfect. There should be 2 more coming up.
Okay.
Yeah. We can use the oh, which one is it connected? Oh, yeah, just put it in. Well, I guess we won't have this door for now. I'll fix this. So you'll have one more point though. That's very common. Yeah. Yes, we are. Okay, so okay, and then before you do that, I don't know whose phone that is, but it's gonna fall down. We're gonna move this table right now out of the way. Yeah, bring it over on one side. Do you guys need wait, no. Yeah, I'm thinking of bringing it like that. You're going to need to dust the distance away now. Yeah, I will. Okay. Can I get people to help with moving? It's not heavy, but it's very good. Alright. So, do you see the 4?
There's still 4. There's 5 points, but it's all concentrated on the bottom half of the screen. There's 5 points.
Oh, yeah, but 5 points is good. Yeah, the ones that aren't. If they're at the bottom.
Yeah.
Oh, okay, I see what you mean. The camera needs to move up. So the camera needs to move right or left. Sorry, it's seeing them like they're at the edge. Once the thing moves, it won't see them anymore. No. It just needs to move linearly that way. Okay, pause for a sec. Take a step to the right. Step to the right, and if you can do a step forward, that would be. One more step forward. Yes. Okay. That much. Yeah. Okay. Like if it's falling, it's falling. Yeah, I know. I just don't know how many like. Yeah, I guess you should be good. It seems the top one. I mean, it's not going to move up and down, so you should be good. Yeah. Okay, we're good. Let's make sure it's all. Yeah. Okay. Can I have someone for the filming crew? Can I have someone sit here with the camera, just in case? It's nothing's gonna happen to it, don't worry. It's fully locked in. I just leave.
You're gonna leave?
Yeah.
Okay.
Don't want to be.
Yeah,
Don't want to be liable. Can I get that, or will they be?
Or the public, we're gonna go.
No,
I gotta go to site tomorrow, 7 in the morning.
I just want sorry.
Oh, I forgot about it. I'm sorry. It's okay.
And then insert position
Yeah. My right. Do you know how long it's gonna be? Like, I mean, like, just get it, like, one test. 5 minutes. Like, how long is it gonna take? Like, just get it. Yeah. Oh, wait. Yeah. So I'll be going.
Sorry about that.
Yeah, no worries. Sorry. Thank you. Thanks. Bye. Bye. Yeah.
So I need one person to be first on that. Perfect. Yeah. And I'll say, and then everything that goes past is 4. My understanding is basically like, yeah. So I guess let's just try 1 second. So 1, 2, 3, 4, 5, and then saving post processing, and then we'll go to it. Oh, maybe we just take the file. I'll see. Yeah, all right. So applications. expected to be the destructive test output 2. So let's start off with a very small amplitude sine sweep test. Give me 1 second to go through this for a second. Give me 2 minutes. Unfortunately, we need to reclock the speed function, but it should be pretty fast.
So you gotta let me know.
Yeah, I'll let you know.
Okay.
right, I'll also say for you guys the position and the acceleration of time histories of the shape tables, okay?
Yep.
All right, are we ready on the camera to measure?
Sorry, anytime.
Yeah. So start the cameras. Perfect. Okay, cameras over there are good. Everyone's ready?
Yep.
We'll start with the sweep with a ground acceleration of 0.2 Gs and a maximum displacement of 5 millimeters. Hopefully, it should be very, very low amplitude. It should be safe. Okay. Starting. Good. Think a little bit excessive, eh? Oh. Yes, this is just like the high frequency, low amplitude, because we didn't want to have high frequency. All right. Yeah, just okay. Yes, very good stuff. So this went from 0.3 second period to an 0.03 second period, which should capture from 2t to 0.2t. So hopefully it should capture at least 2 or 3 of your modes, and we'll find that out when we do the Fourier response vector. Right? That's Fourier transform. Okay. So that's good. We also have a white noise function which should just go through all the frequencies and do the exact same thing. This one was developed by Myron for you guys in 2018. But in 2018, the competition was also a little bit more fierce, so we just scaled it down by a factor of 0.1. Yeah, so there's just like this. And then yeah, just say that as sweep or chirp, whichever one you guys prefer. And yeah, so I'll just say plots here as well. Daniel, in the past have you used mat files or M files?
Either should be okay, but I don't remember off the top of my head. Both can be accessed from MATLAB, right?
Sorry,
Both
can be
yeah.
accessed through MATLAB.
That's fine.
So this will be the sweep, sweep underscore app.mat. And I'm gonna create an new folder for you guys. ERI 2022. And then this one, file save as MATLAB, and then this is sweep.displacement. So please remember that the accelerations I'm giving you are all in G's, and the displacements I'm giving you are all in centimeters.
Yep.
Okay. Do you have limitations on the length of variable means? Okay, this is. Okay, so the next set of tests will be the last file. I'll just get Daniel a hard hat so I can get into the system. Is the phone set up for the next test? Grace,
Yes.
if it's fine with you, I think we should do GM1 first and then do the white noise because the sweeps already kind of captured, before you put your phone and page up, the sweeps already captured the, more or less going to capture the frequency response content, but the white noise, because I'm not the one like that wrote it, I just took the file, I'm fairly certain it will be fine, but I'd rather have at least one validation test first with the low amplitude motion and then move on to the white noise. Is that okay with you?
Sure.
I think GM1 won't be a problem at all. Your structure, I've tested it. I looked at it today on the big table. It had very low accelerations and displacements, so you should be good. It does have a nice little kick at the beginning, goes boop, and then it starts slowing down again.
Kaisen, could you get the phone down?
Yeah,
For
take your phone
GM1.
down just in case your power fails on GM1, but it's pretty low amplitude. I don't expect it to hopefully fail. Yeah, so I'll load up GM1 and then we can give yeah, I'll do that. So we'll start first with the GM1 and then we'll do the white noise in between GM1 and GM2. Just in case, I mean, I don't expect GM1 to be a problem for your power at all. GM1, ERI. Okay, so we're opening up again the command position and the cable. So again, we want the cable accelerations and the cable position G's and centimeters respectively. We are ready over here. How are we moving over there?
Yep, ready.
Okay, and me and Daniel are also going to be ready in position. Daniel, if anything happens, just press that red button. It should shut down the cable. This is at home, so we're good in the center. Are we done on there? Are we good there? Start recording. Okay, GM1, starting. Boom. That's it. Yeah, but better safe than sorry. Okay, and then we'll run the white noise, and then we'll run GM 2. So remember to save your files. I'll save my files up here as GM. Save it as GM1, right?
Yeah.
Okay.
And then typing it onto the phone on for what?
Yeah. And does anyone here have a flash drive or something so you can take this data afterwards? If not, I can give it to you later. Okay.
I have a hard
Okay. Yeah, you don't have to get it right now.
Okay.
I mean, get the laptop out of the way and I need to. I mean, I'll try to figure out a way. Maybe you know what? This board is not being used, so I will put it right by the and hold it there just to protect the equipment a little bit better. Very low, but it's a very high frequency, low amplitude. It can be like a lattice. That's why I said that's from GM1. But I purposely pulled my way. I ran the original file and it just went boom. I was like, oh, okay, okay. I'll show you guys the 2018 competition earthquake. You probably remember, right? It like just completely destroys the structure. I thought Luis had just written up like a thing that just goes between the ends of the, like I thought he wrote up a program that just tests the ends over and over again. Yeah. we're running the white noise ground motion to go through as many frequencies as possible and identify what the modal parameters of this building are. So on start cameras.
Yeah.
Okay. And me and Daniel will be over here. Yeah.
E4 is not. L4 is not.
Yeah, one of them won't be reading. Yeah. Okay. And we are good to go. Starting the. Okay. Starting white noise in 1, 2, 3. No, you're good. I just heard some, but I mean, we've gotten, at least 15 seconds of data, but we can try it again because it stopped short of everything. No, I don't think so. Don't worry about it. I actually thought it stopped because I actually got really scared for your structure for a second there. Well, the phone is the only thing recording. Yeah. Yeah. You just want to, Grace, how do you want to do this? So, we've lost the data over here, but we have the displacement data, right? We have the displacement data, we have the phone data. Do you want any of the information about, the acceleration, I can just give you the acceleration file. So do you just want to move on to GM2?
Sure.
Or do you want to redo this test and get the acceleration?
Yeah. Follow
Okay.
is.
Yeah, so tighten the phone up and can someone from the team just come and see if your structure sustained any damage, just so that we're sure of it? I don't think it has at all, but it's good to do a preliminary analysis so that Yeah. It's maybe we need some because it sticks. Like you'll see a little jump in acceleration where it just yeah. I'll tell you what, this time, watch the hour, and if I need to stop it, I can stop it from there without, no. No, I want it to break, and I still want it to break before the ground motion. I don't want it to break. I want it to perform however you guys intended it to perform. So whatever your intentions were, I want that to happen. I don't want it to break on invalidation.
You might look better without the art.
Yeah. I'm a warrior boss.
No, it's okay.
Just take my fucking phone. Wait, that's your phone. You sure you want to keep it up there during GM3? No. Oh, flying for windows.
Yeah, I didn't know that like it will break them. I thought it would like I kind of did think like I thought it was gonna break and then like
Most likely, we're going to break much.
yeah. Okay. Yeah. Okay. Cool. Your phone's attached. All right. Let me know when you start recording.
Yep.
Okay. We need to stop. I'm not going to stop it. I'll stop it. Yeah, unless this breaks, then
Are we not doing one?
I'm doing one goes one more time.
Okay.
And you said the phone.
Yeah, yeah.
Right. So, yeah, we're good on the camera, guys. Over there. Yes. Okay. Okay. 1, 2, 3, start. Okay.
What I noticed is that this thing is in that position.
Yeah. Yeah, these all
My side is clean, but there's this weird, not on the other side of the thing.
I'm so sorry. I mean, I saw that smart when I tested it. Yeah, at least. Yeah, yeah. Well, yeah, maybe not.
Well, there was one last year.
So, and like I told you, I asked what you were on. He was like, oh, I was like, yeah, when you start to do this, like, to the end. Yeah, you're gonna likely drop. Hopefully not. Hopefully this does a lot better. I mean, because you guys have the data that you're telling me. You're saying like, go this, do this, and do that, but it doesn't mean that the table can be created. So, yeah. So, if it breaks, I'll stop it from here. Okay, guys, we're running the last ground motion. So, there's no phone, nothing. Me and Daniel are prepared to catch it in the event that it breaks, but hopefully it doesn't. If it does, we'll hit the stop button digitally, not manually. If that doesn't work, I'll tell you, okay, like Daniel, stop. We're going to stop, and then we can hit the stop button. Are we recording on camera over there?
Okay, starting now.
Okay, are we recording on camera over there?
Yeah.
Okay, everyone excited for GM2?
Yeah.
Yeah.
All right, you team Seismic Design team.
Yeah. Starting in 3, 2, 1, go. Yeah, stop.
All right, congrats.
On the tower, I guess you guys have a couple of options right now. Make sure you save your files. I'll make sure I save my files. You guys have a couple of options, I guess. We can, one, do a more destructive sweep test and like just capture as many frequencies as we can until it breaks. Two, you can, I have some of the previous year's ground motions. We can, I think it's okay to run them. We can, like, the table will definitely perform. I can't say anything about your tower. It might not be designed for it. We can do that, which I think the former is more useful to you guys. Do you want to do that first? Or, yeah?
Yeah.
Okay. Cool. So we're going to do like a more aggressive sweep.
Oh, there's nothing left, like, it's just in case they get more value.
But the first sweep has a very low amplitude towards the end, and I'm actually not sure it's like actually. And the white noise is good. The white noise is really good. It was really good. So. Oh, okay. Yeah. If you don't want, yeah, I thought you just wanted the tower to break, but.
You guys want to cut the power for breaking or not?
You can always take it.
No.
Oh, okay, then take it.
But we do. I think the first one, I didn't.
Okay. Okay, I'll let it run for like the low 0.2 Gs, and then I'm gonna cut it off. Okay, so I'll let it run for about like 10 seconds. Once I can show you guys. Yeah, I can't show it to you guys, but yeah, I can cap it off because it's gonna be constant displacement, so your acceleration will keep going up. So frequency is getting compressed, right? So your acceleration is gonna go 0.2. Like I've seen it go up to 0.6 before I stopped it. I think at that point it'll probably break. It might break your tower. I don't know. I think it's good.
No, they do it.
I definitely heard it crack on GM2. It's up to you guys. This is more of a team leader decision for you guys. Oh, you want to do GM1 again? But you're not going to do that. That I only know one for sure that will work, which is the 2018. It's strict. It's like harsher than the GM2 that you just. It will definitely break it down. 100% of it. Yeah. Like if GM2 now after the crash, GM2 2018 crash, I think that's pretty done. just have one file that's like, yeah, I need this file for that. I mean, if anything, like, if you have everything, take the data, process it, see what you get, do the fast Fourier transform, see if you get your frequency, see what kind of data that you got, especially the white noise. I feel is very useful for you guys. See what you get, and if nothing else, I mean, you can reevaluate and have another meeting about the distribution. And also then you can stay in the lab. Yeah, exactly. We don't have to do a live. Okay. So you guys, yeah. So you guys can sponsors however you want, and I'll just start saving these files. Perfect. Yes.
All right, thank you everyone for watching, for staying with us for about 2 hours. The shake test is officially over, and thank you all for watching. Thanks again to our sponsor, and thank you, Marijuana, and support from our faculty advisor, Christopoulos, and then Myron as well. So thank you, and stay tuned for the next shake test.
And then someone please get me a flash drive. I'll give you the files that I have right now, and we'll try to get the files that we have on the computer there as well. Also, for anyone recording the GM2, would you mind sending it to me? I think it's very, very neat to see